Okay. So before we discuss this one, we go through the classification of the organic reaction mechanism, how many types of organic reactions are possible, etc. First of all, I just ask you one simple question. Do you have the idea about the addition reaction, substitution reaction, etc.? I think you have read in class 11, 12 about the addition reaction, substitution reaction, etc. Anyone please tell me what is substitution reaction? Anybody from the class? Yes? Yes? Any answer from you? What is substitution reaction?
Ma'am, one
Yes.
functional group is replaced by another functional group.
Achha. Very good. Very good answer. But I'm just asking you, give any natural, no, in our daily life example of substitution. Daily life example of substitution. Any idea? Why we read this term substitution reaction? Yes. Yes. Anybody? So let us start first, okay? I'm going through the PPT right now. Will you go through this type of PowerPoint presentation? You go through the screen? Yes? Yes. Okay. So we start about organic reactions it is the bridge between your 11, 12 and BTech first year courses. So first of all, I am discussing about the first slide. This is the first slide, but second slide I'm just go through it. Organic reactions. What is organic reactions? So organic reactions are mainly, we can go through it. So first of all, organic reactions. How many types are possible? Organic reactions, anybody from the class? Yes. How many organic reactions are possible? Anybody? Yes. Yes. All have joined right now? Yes?
Ma'am, substitution reaction, elimination reaction, addition reaction, radical reaction,
Okay.
oxidation reaction.
Okay. Very good.
Redox
Okay.
reaction.
Redox reactions means oxidation and reduction, both of them are there. Okay. And you just go through the PPT. First of all, I am considered that addition reaction, substitution reaction, elimination reaction, pericyclic reactions, rearrangement reactions, and redox reactions. Okay. So I'm just making it by the red color about the substitution reaction. Today we discuss the basic thing, basic concept of the substitution reaction. In our daily life, when you go through the, say, as for example, this is the change in our nature, evolution process. When you go through the evolution process, you observe the thing that the nature change, the genomic code is added one by one. That is, this is nothing but the substitution. Substitution reaction in our social daily life, it is also we observed. Okay, some election procedure, what happens? One prime minister is substituted by another. This is also the process for the substitution. So substitution is everywhere in nature. If you consider alcohol is present, but we don't like this compound ROH, this alcohol. We just want to substitute alcohol by the halide groups, say RCl, RBr, RI, etc. So in that case, definitely we can consider that we can replace the alcohol group, that means ROH group, by the chloride group RCl using the substitution reaction. That means if I consider that alcohol is present, ROH is there. Now if you add some chloride, Cl minus is there, OH is replaced by the chloride ion, and we can get the compound RCl. So this is an example of the substitution reaction. Now if you consider the addition reaction may we go through that, say double bond is there. In the double bond, if there is the addition of HCl, HBr, etc., we can get the breakup of the double bond, and H and Cl will be added. Elimination reaction, we will discuss everything in part by part, but today we just give the introduction about elimination reaction. Means in that case, say alkyl halide is there. From alkyl halide, if HCl is removed, we can get the double bond. Pericyclic reaction, this is the molecular orbital interaction. It is the new thing for your subject. Another is rearrangement reaction. In that case, we observe that sometimes stable carbocation is much more predominant, and there is a shifting of the alkyl group, and we can get the much more rearranged product. This is called the rearrangement reaction. And last one, redox reaction. This is oxidation and reduction. Both processes are going on through the redox reaction. But today's discussion, main thing is called the substitution reaction. This is clear to you? Yes? Yes? Anybody? Substitution reaction? Just so please tell me, give one suitable example from the organic part. Give that, this will prove that this is going through the substitution reaction. Any example, please tell me, anybody. Anybody, please tell me, give one example of the substitution reaction. Yes? Anybody?
Ma'am, Sn1, Sn2.
Nah, this is not the example. This is the classification. I will come to this. You just think. I'm just calling you that if you know that R alkyl chloride is present, okay? RCl. R क्या है? Alkyl group CH3 and Cl is present. In that CH3
ROH plus HX.
ROH
plus HX.
Then
plus
what
HX
happens?
equals to RX plus H2O.
Very good. So that
Ma'am,
means
halogenation.
halogenation. Example, please. Example. Yes. Very good. Example. So we can consider that if ROH group is there, we add Br minus. So OH minus is replaced by Br minus, and the product should be RBr. Okay, that means OH minus is replaced by Br minus. If I give the example that former prime minister and the current prime minister, former prime minister is replaced by the current prime minister. So this is the substitution process in daily life, socially. And if you consider the by natural process also, this is the example of the substitution reaction. And I am going through that, already told you that evolution process, etc. That is why substitution is so much important in our daily life. Clear? It is clear? Any doubt, anybody, any question related with this? Anybody? Yes? Yes? May I go to next slide? Yes, please. May I go to next slide?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
So I am come to the next slide. This is our slide 2. Before we discuss this one, we come to the point, very important, nucleophiles. So we discuss about substitution reaction, and substitution reaction का सबसे important part क्या है? Nucleophile. Clear? What is, now anybody please tell me what is nucleophile? Please, anybody tell me what is nucleophile? Any idea, anybody? What is nucleophile? Yes? Any answer from anybody?
Ma'am, halogen ions like I minus, Cl minus, Br minus, they are
Yeah, I'm
nucleophile.
just asking you, what do you mean by the term nucleophile? Nucleophile क्या है? The term.
Ma'am, a molecule that has a tendency to donate electron.
To donate electrons.
Electrons.
Okay, very good. So I am just go through the term. You understand that nucleophile. That means nucleo means nucleus. Nucleo means nucleus. This is the nucleus का charge क्या है? Positive है. And phile means it is loving. Phile means it is loving. So nucleophile means nucleus loving. Nucleophile means nucleus loving. So if you consider nucleus loving, you understand this thing. Nucleus loving का meaning क्या है? The species which loves the nucleus. That means which loves the positive center. If the species loves the positive center, that means the species must have negative charge, definitely, or the species must have a lone pair of electron. So the species must contain higher electron density. Clear? Any doubt, anyone regarding the nucleophiles? Any question, anyone? Anybody? Yes? Yes. So we can consider that a reagent which can donate electron pair, we can consider this is the nucleophile. Nucleo का meaning क्या है? Nucleus. Phile means loving. So they are electron rich. They may be negative ions or carbon ions or molecules with the free electron pair or the molecules with the free electron pair. And last one, we can consider that the general symbol for the nucleophile is Nu. The general symbol for the nucleophile is Nu. Clear? Yes? Any doubt, anyone regarding this nucleophile? Any doubt, any question? Yes? So I am asking you to give example of the nucleophile. आप लोग एग्जाम्पल दो. That means the nucleophile means positive center loving. So please give example. Nucleophile का example बताओ. Yes.
I minus Br minus.
Very good. I minus Br minus or anybody please tell me example of the nucleophile.
Cl minus.
Very good. Or
A compound with lone pair of electrons at NH3.
OH minus,
example. Very good. Or जो भी example है.
minus,
क्या क्या बताया?
Cn minus,
हाँ, very good.
OH
और
minus. OH
NH
minus.
OH minus. एक ओके वेरी गुड. एक न्यूट्रल न्यूक्लियोफाइल का एग्जांपल दो. एक न्यू
ammonia,
एमोनिया. वेरी गुड. और
H2O.
H2O. वेरी गुड. और
Iodine.
आयोडीन. ओके वेरी गुड. और
ROH.
okay. Oh, okay. So that you get this point. Clear? So we just read about substitution reaction and we just read about the nucleophile. Now I just want to compare some basic idea about the nucleophile means nucleophilic property. This is called the nucleophilicity and you know this very much. I'm just comparing the nucleophile with their weak and strong tendency of the nucleophile. So I am coming to this point. Say comparison between nucleophiles. First of all, I am just give the basic idea about the their nucleophilicity. If you compare RS minus and RO minus, okay, which one is much more nucleophilic? Anybody, please? Answer is given. That means RS minus is much more nucleophilic than RO minus. It is given. Now the question is why? Why RS minus is much more nucleophilic than that of the RO minus? Yes. Anybody? Why RS minus is much more nucleophilic than RO minus? Anybody?
due to large size of sulfur.
This is one point, but go through. Very good answer. But another point, please go for the basic thing. RS minus,
Less
RO minus.
electronegativity of
Very
sulfur.
good answer. Very good answer. That means this is the correct answer. RS minus, RO minus. Think. RS minus is nucleophile. Why RS minus is nucleophile? Because RS minus के ऊपर there is a negative charge density. But RO minus also nucleophile because RO minus also some electron charge density is there. Okay. But question is, if you put one positive charge, then RS minus will react very active, very strongly than RO minus. Reason क्या है? क्योंकि RS में, in the RS minus, the negative charge present on the sulfur, but in RO minus, the negative charge present on the oxygen. Electronegativity is of oxygen is higher than that of the sulfur. So definitely oxygen will try to control the electron density of the present on the oxygen, but sulfur में जो electron density present है, this will be very loosely bound. As it is loosely bound, so it will very easily attract with the positive charge. And we can consider that RS minus has higher nucleophilicity than that of the RO minus. Clear? Any doubt, anyone? Any question regarding this? Yes? Anybody? Any question? Okay, thank you. Okay.
No, ma'am.
So next we can come to the another example, say I minus Br minus, and I have already give you the clue how we can compare the nucleophilicity. Please tell me who, I minus is much more nucleophilic than that of the Br minus. Please explain why I minus is much more nucleophilic. Explain it. Yes.
And because iodine is least electronegative.
And you get the answer. Clear. As you must write down that when I minus is less electronegative, so definitely the electron density which is present on iodine will be loosely bound than that of the Br minus. So it will be much more free, much more easily attached with the positive charge or positive center. That is why I minus has least higher nucleophilicity than that of the Br minus. Clear? Any doubt, anyone?
No, ma'am.
So I just go through the next slide and you just read. Next slide. Here we give some few example regarding the nucleophiles and charge, and you please tell me the idea. The factors which are affect the nucleophilicity. The factors which affect the nucleophilicity. If I consider HO minus and H2O, which one is much more nucleophilic? HO minus and H2O, which one is much more nucleophilic and why? Can you explain? HO minus and H2O, which one is much more nucleophilic? Yes. Anybody from the class? HO minus and H2O, which one is much more nucleophilic? Yes. Anybody? Yes, very good. Anurag said that this is HO minus, but why HO minus? Why not H2O? Yes.
Due to greater negative charge.
Very good. Due to greater negative charge. In H2O, there is lone pair of electron present, but HO minus electron density is much more. So here we should not compare the electronegativity because H2O, oxygen is present. HO minus negative charge, on the oxygen there is negative charge. So we should not compare it because charge density is higher in HO minus than H2O. So definitely HO minus is much more nucleophile than that of H2O. Clear? Any doubt, anyone? Any doubt, anyone? Yes? Now we can consider that NH2 minus and NH3, same thing will happen here also. NH2 minus is much more electron charge density on the nitrogen than that of here, and NH3 there is just lone pair of electron is present. So we can consider that NH2 minus has higher nucleophilicity than that of the NH3. And simple case HS minus and H2S, same thing, HS minus and H2S also. And if I consider the electronegativity difference, you also go through that. Now I am just ask you one simple question. CH3 minus, NH2 minus, OH minus and F minus, which one has highest nucleophilicity and why? CH3 minus, NH2 minus, OH minus and F minus, which one has highest nucleophilicity and why? Please give the answer.
F minus, because F minus has more electron density.
No, you are just right now you are confused. Okay, please tell me CH3 minus, just CH3 minus, NH2 minus, HO minus, F minus. Okay, which one has a higher electronegativity? Definitely fluorine. Definitely, na? If fluorine has highest electronegativity, तो सबका ऊपर चार्ज क्या है? सबका ऊपर जो चार्ज है, दिस इज द वन नेगेटिव चार्ज, CH3 minus, NH2 negative, OH negative and F minus. But negative charge is present on the highest electronegative atom. So जो जिसका इलेक्ट्रोनेगेटिविटी ज्यादा है उसके ऊपर अगर नेगेटिव चार्ज रहेगा तो क्या होगा? It will attract more this negative charge. Clear? So this negative charge is not free to donate with the positive charge. Clear? Clear? Yes. सोचो, CH3 कार्बन के ऊपर जो नेगेटिव चार्ज है, कार्बन is not so much electronegative, so it will easily give its electron density to the positive charge. But fluorine is much more electronegative. तो क्या होगा? इसके ऊपर जो नेगेटिव चार्ज रहेगा है, it will attract much more this electron density towards itself. So it is not easily, it is not loosely bound. It is not easily attack the positive charge. So CH3 minus is much more nucleophile than that of the F minus. But highest nucleophilicity, if you compare F minus, chloride minus, Br minus, iodide minus, which one has highest nucleophilicity? I minus has higher nucleophilicity than that of the F minus. Here reason hai, I minus has least electronegativity than that of the F minus. Clear? Any doubt? Any question? Anybody? Anyone? Yes? Clear? Okay. Shumit, it is clear to you? Yes?
Yes, ma'am.
Yes, that means when you consider the charge, if the charge is more, so we have to consider charge density is much more. We have to consider nucleophilicity higher, generally. But when the charge is present on the much more electronegative atom, it will be much more less nucleophilic in nature. Clear? Clear? So I am just go through the next slide. This is simple thing. This is called the electrophile. Anybody? Nucleophile we discuss. About right now we can consider about the electrophile. Anybody please give the example of the electrophile. Anybody from the class? What do you mean by electrophile? Yes. Anybody? What is electrophile? Acha, Utkarsh give the answer that this is Na plus. Okay. Na plus is the electrophile. That means electrophile. That means electron loving. So electron loving means negative charge loving. So it must be positive, or either it is positive or it may be that like Bf3. It has no positive charge, but it has no positive charge, but it has least, its octet is not fulfilled. Because it has how many electrons in the Bf3? 6 electrons are there. 3 electrons in each F electron Bf bond. 3 into 2, that means 6 electrons are there. It is octet is not fulfilled. So we can consider that it is the electron deficient species. So if you consider the electrophile, you can go through the example that a reagent which can accept an electron pair. The electrophile means electron loving, so they are electron deficient like Bf3. They are positive ions or neutral species. They may be positive ions or neutral species with electron deficient center. An electrophile can be represented by E+. The term is called the E+. Examples of the electrophiles are H plus, Cl plus, Br plus, Bf3, etc. Because you know these things, Cl plus, Br plus also possible. These are the good example of the electrophile. Now I am just asking you one question. If I go through why Bf3 is an electrophile. Anybody? Why Bf3 is an electrophile? Anybody please give the answer. Why Bf3 is an electrophile? Yes. Any answer from you? Why Bf3 is an electrophile?
Due to high electronegativity of fluorine, the electron cloud will shift towards fluorine and it will get.
Very good. This is one of the answer. Another reason BF3. BF3, when you go through this BF3 term, how many electrons are present in the BF3 outside BF3? 6 electrons, na? BF bond, how many BF bonds are there? BF bonds are there, and there are BF bonds is 3. Each BF bond containing how many electrons? 2 electrons. So 3 BF bond must have 6 electrons. But generally, octet fulfillment tells us that it should be 8 electron. It should have 8 electron. That means it is the electron deficient species. So it want to drag electron. That is why BF4 minus, that is NaBF4, BH4 minus is very common in the nature. Exactly. This is the reason, and as it is get the electron, it will fulfill the octet and it is behaves as a neutral electrophile. So this is the example. Now, I'm just go through the another example. Say another portion of this. What is substitution? This is the example. What is substitution? Here we get the example of different kind of CH4 plus Cl2. CH4 plus Cl2, we get the CH3Cl. That means one hydrogen is replaced by chlorine. One hydrogen is replaced by chlorine. So there is a substitution of hydrogen by chlorine. This is an example of the substitution reaction. That means H is replaced by chlorine. Another example of the substitution reaction is, say, CH3CH2I. Say if I consider CH3CH2I and KOH is there. I minus is replaced by OH minus. That means we get the CH3CH2OH plus Ki. So alkyl iodide is replaced by the OH minus and we can get the alcohol. This is an example of the substitution reaction, and vice versa also true. If you use that CH3CH2OH plus Ki and OH is replaced by the I minus and we get the product CH3CH2I. This is also example of the substitution reaction. Another very good example of the substitution reaction is, this is the example and I am asking you one question. This is very important part of this substitution reaction. HNO3. From this HNO3 side, we can get the NO2 plus. When you get the NO2 plus and this NO2 plus substituted the hydrogen here and we can get the NO2. That means hydrogen of benzene ring is replaced by NO2 plus group, not NO2, NO2 plus group. So among the, I am just discussing 3 examples: CH4 plus Cl2, CH3Cl, CH3CH2I plus KOH, CH3CH2OH plus Ki, and benzene plus HNO3 in presence of H2SO4, we can get the nitro. Now the question is, can you give the example? Which one is the example of free radical substitution reaction? Anybody, which one is the example of free radical substitution reaction? Anybody? Anybody from the class, please tell me which one is the example of free radical substitution reaction? Anybody? Yes? Yes? Any answer from you? Which one is the example
The
of?
first one.
Exactly, this is the very good answer. First one is the example of free radical substitution reaction. And which one is the normal? Generally, we think that. Why we discuss nucleophile and electrophile? Because substitution reaction is, free radical reaction is possible, electrophilic substitution is possible, nucleophilic substitution is possible. Give example of the nucleophilic substitution reaction from the from the slide. Which one is nucleophilic substitution? Yes. Which one is nucleophilic substitution? I'm just go through the slide.
Second one.
Second one, because OH minus, this is the nucleophile is substituted. Negative charge, it is substituted. And you know this thing, that remaining part should be electrophilic substitution reaction. Why this is electrophilic substitution reaction? Because NO3 from HNO3, NO2 plus electrophile will be generated, and it will replace the hydrogen of the benzene ring, and NO2 plus is incorporated into the benzene ring, and we can get the aromatic nitro compound. And this is an example of the electrophilic substitution reaction. Clear? Any doubt, any question, anybody from the class? Yes, anybody? Now, I just go through the next slide. Okay. Classification of the substitution reaction. Classification of the substitution reaction. That means we read the, according to the use of electrophile, nucleophile, free radical, etc. We can divide it by the electrophilic substitution, nucleophilic substitution, and last one is called the free radical substitution. But this is the main thing for the classification of the substitution reaction, and we can declassify this substitution reaction by three. Generally, you read, I think 11, 12, you read that this is the two part, Sn1 and Sn2. But there is also an one part is there. This is called the Sni. So Sn1, Sn2 and Sni. For Sn1, Sn2 and Sni part, you must remember one thing. You should write down in that way. S, capital S, stands for substitution. In the subscript, we mention that N. This stands for N, nucleophilic, and 1 stands for unimolecular. 1 stands for one molecule, unimolecular. This reaction is called the Sn1 reaction, and it is go through the carbocation pathway. Why carbocation pathway? We discuss it. Next, Sn2 reaction. S, capital S, N in the subscript. Don't write S and N in the same line. Please mention capital S Then in the subscript, please write down N, then 2. Substitution, nucleophilic, 2 stands for bimolecular. And it is go through the pathway. This is called the TS. That means transition state pathway. And last one, we considered that this is the Sn2. Sn2 का meaning क्या है? Sn2 means this is the new thing. Substitution, nucleophilic. I stands for internal. I stands for internal. So we can classify the substitution reaction by 3 parts. One is called Sn1, next is Sn2, and last one is called the Sni. Clear? Any doubt, anyone? Any doubt, anyone regarding the classification? Okay. Sni, this part, we will read it. I means internal. That means no requirement for different nucleophile, different transition state. We just, this reaction is fully internal process. We discuss this one later. But today we discuss Sn1, Sn2. Just a brief idea what is which type of reaction going on, why it is carbocation pathway, this, etc. Before discussing this, I just give you one example for Sn1 and Sn2 mechanism. This is very interesting. Simple thing for mechanism of Sn1 and Sn2. You observe that from the mechanism, you understand that there is a, this is the, one cat is there, gray color, and one cat is yellow color cat is there. Sn1 case, what happens? In case of Sn1, this is the position. That means it will not jump into the bed of the gray cat. First of all, gray cat should be removed and then yellow cat will take its position. But if you consider the Sn2 pathway, in that case you observe that the yellow cat and ash gray color cat both are sharing the same bed. This is called the Sn2. That is means it is transition state pathway. And this is Sn1, this is the carbocation pathway. Here, this is the basic difference. That means this both are give the same, starting from the same compound, we get it, and product also the same, but difference between them according to their choice. That means in case of Sn1, just only gray cat sharing the bed. Then after remove the gray cat, yellow cat will come to the picture. But here we observe that both yellow and gray cat at a particular time sharing the same bed. So this is the example of Sn2. Anybody from the class, can you explain this example? Anybody from the class, can you explain this example from the mechanistic point of view of Sn1 and Sn2? Anybody from the class? Yes? Yes? Can you explain the example from the class? The example? Sn1 is second step, Sn2 is first step. Okay. Or anybody have any idea about Sn1 and Sn2? The first thing, we can go through it. That means, say next slide, say I just give the example for Sn1. this is the Sn1 mechanism. If you consider this is the Sn1 mechanism, in this mechanism, we go through that. So this is carbon. This Z is, this is one group is present here. Z is very close to our eyes. This is far from our eyes. And X and L is in the same plane. First of all, there is a formation of the, in the slow and rate determining step, there is a formation of the carbocation C+. There is a formation of the carbocation C+. Then this is the carbocation form. That means leaving group is just removed, and that there is a formation of the carbocation. After formation of this carbocation, the nucleophile will attack. After formation of the carbocation, the nucleophile will attack. But if you consider some example, you can easily understand that. Just I am sharing this from yes. Say, as for example, in that case, slow reaction rate, if the reaction rate is very slow, we can get the carbocation first formation. And after getting the carbocation, it will be attached with the nucleophile. And when it attached with the nucleophile can attack from this side, and or it can be attacked from this side. So both sides are open. As the nucleophile can attack from both sides, so if the nucleophile attack from this side, we can get nucleophile is attached from this side, and this is the product formation. And if the nucleophile attack from this side, it will attack from this section, and this is the product formation. So from that section, we just go through this example. You just know that Sn1 mechanism, there is these two cat can share their bed at a time. First of all, there is a gray cat will form this, this will remove, then yellow cat will come and substitute its position. But if you consider the Sn2, in that case, yellow and gray, both are sharing. That means if I just go through the example, you understand that for what happens in the Sn2 case, Br- is there. And if Br- is attached from this side, Cl-, the leaving group, both are present. That means we can consider that this is the sharing of the bed. Yellow cat and gray cat both are sharing. So we can go through that. Sn2 Br- is forming new bond, Cl- is leaving, and at last we can go through that Cl- is completely leaving and Br- is attached. So you just go through it, that about this up to this slide, you just remember that Sn1 reaction is going through the intermediate pathway or carbocation pathway, and Sn2 reaction is go through the transition state pathway. Now I have a question. What is the basic difference? What is the basic difference between the, yes, 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 anybody from the class? Yes. Yes, anybody? Any question, anybody? Yes, very good answer. Sn1 is two-step. In Utkarsh give the answer is two-step, in which first step is the slow and second one is the first. But Sn2 Sn2 is one step and first reaction. Is it? Not always that Sn2 is a spontaneous reaction. This is the very good example, very good. So you understand it. Right now, I am just give you from the once soft, you can understand this one. Say, I just take one example. Say, as for example, for Sn1, here I am writing here for Sn1, say carbon is there, alkyl halide group is present, R, R dash, R double dash, anything, any group you can suggest it from that, and Br is present, bromine. After that, we can observe this. When this is formed in the Sn1 pathway, there is a just one step. First step is the slowest step. So what happens in the first step? There is a formation of very stable carbocation, and when there is a formation of very stable carbocation, we get that this is the first step, R dash, R double dash. This carbocation when formed, then we use in the second step, nucleophile will be used. Say OH minus is the nucleophile, and when this nucleophile will be used, we can get there is a formation of the compound alcohol. So we can consider that Sn1 reaction is both going through the two-step reaction, but Sn2 is just only single step and spontaneous reaction. And this is the beauty of the Sn1 reaction. It is go through the carbocation or intermediate pathway, and which we can trap. But in the Sn2 reaction, we can't trap the transition state because it is go through the first transition state pathway. So from the next class, we discuss about the mechanism of the Sn1 and Sn2 pathway. Clear? Any doubt, anybody? Any question regarding this? Anyone? Yes? Yes, ma'am. Acha. Okay, thank you. Thank you. So from next class, I think it will be in the next Wednesday, we discuss about the Sn1, Sn2 reaction. So thank you for all. And you just go through the different types of, read this thing, this introduction purpose, what is Sn1, Sn2, explain this, okay? And if you have any question, any doubt, so next class we will discuss it, okay? Thanks a lot. Okay, thank you. Thanks. Okay, anybody, any questions, any doubt?